Okay, I'll be right with you. I'll be right with you. I want to set up our materials. Okay. So we spent the first few weeks of the semester talking about how to do basic coding with Java and not using any GUI interface. Basically, that was all discussion about how to create a model. And then we spent last week talking about how to create some basic Java GUI elements, which would be the view. And now this week, let's talk about how to tie the view and the model together so that we can get basically a controller and complete the model view controller pattern. Here's the outcomes for the week. There's only 3, but they're all substantial. So I'm going to recommend several times that you look at the code that I provided online and that you play with it and that you practice making your own little GUIs, not necessarily related to your project, but just practice making the GUI from scratch. See if you can do it. See if you can get some kind of an interaction to happen. Today, we're going to talk about some simple interactions where we connect the model, the view to the model. And then on Wednesday, we'll talk about creating something called timelines, which are effectively animations so that we can, so that you can have those of you that are developing games like the, run away from zombie game where you have actual animations occurring with user interaction. All right, so still using the model view controller pattern and the view, the goal again, you create your model, you create your GUI, and then you create the controller by assigning methods to GUI objects. And those methods are basically going to request that changes be made to the model. We're also still using the JavaFX creation of the GUI. So remember, you have a stage. The stage contains a scene. The scene contains a pane. The pane contains nodes. Those can be text fields. Those can be buttons. Those can be graphical objects. And you can tie or attach methods to every one of those nodes inside the pane. And I'm going to start out with the loan calculator. This is directly out of the Liang text. I don't believe I've modified it at all. The idea is you give the user, well, let me see. Let's just do it. You give the user this graphical interface, and then they can fill in the top 3 numbers. So they fill in the interest rate, number of years, and amount of loan, and then it returns monthly payment and total payment. So setting this up would be the GUI portion or the view. And if you're going to develop this, you ask yourself, well, what do I, go through the process? What classes or objects do I need? And whoever developed this decided to create the loan as its own model, as its own object, and then created the GUI as its own object, and then attached methods so that once you get the text fields filled out by the user and you hit calculate, it fires off the methods to fill in the monthly payment and total payment text fields. Ask yourself these questions. Okay, if I'm going to do a loan, what do I need? What attributes does it need? Oh, it probably needs annual interest rate, number of years, and loan amount. Those would probably be the attributes of interest to describe the loan. What does it need to do? Well, since it needs to return the monthly payment and total payment, we probably should have a method that calculates the monthly payment and another method that calculates the total payment. And then we can call those two methods and fill in those text boxes. So if we look at the loan, here's public class loan. And sure enough, that's the model. It's not seen by the user. They have loan date, but I don't think they ever use it. And to create a loan, you can fill in, there's two constructors. One is the loan with no information given. They assume a 2.5% interest rate, a 1-year loan, and $1,000. Those are just default numbers. But the more interesting one is they created their own constructor, where you fill in interest rate, number of years, and loan amount. Again, the 3 text fields that were filled in by the user on the GUI. And then they just set those attribute values. Now, they use this. I don't think you need to use that. Students tend to overuse this. I would recommend trying your code without that and see what happens. Remember, every method has access to every attribute, so you should be fine. And then what do they have for their methods? Besides the constructors, they have setters and getters. Set the annual interest rate, get the annual interest rate, set the number of years, get the number of years, set the loan amount, get the loan amount. But then finally, the two that are of interest, calculate the monthly payment, get monthly payment. That's a pretty good name, right? We can get a good guess as to what that's doing. And then get total payment. So each method, remember, does a very tiny little thing. And they don't use attributes for monthly payment, and they don't use attributes for total payment because they're following the general rule. If you can calculate it, don't store it in an attribute. And again, they do the date, but they don't actually use the date. So I'm going to ignore that. Then they create the GUI, and the GUI is just what you'd expect. The GUI is going to be a label text field, label text field, label text field, and finally a button. And they do this by creating attributes for the text field and the button. Now, before in the other classes, the other GUI classes, I was complaining because I said with the author's text, they were not giving their graphical entities names. And if you don't give it a name, you can never grab it to get information from it or to tell it to do anything. So here they're using attributes because they're actually using these things. So they do give them names. So the text fields all are begun with a TF. TF, annual interest rate. TF, number of years. TF, loan amount. What is that about? Well, TF is short for text field. Not a bad idea. Name all your text fields TF something. Not a bad idea. It's a little mnemonic to remind you when you're looking at the code what this thing is. Buttons, start it with BT, and then name it what they do. So TF, annual interest rate. I can look at that, and I have a really good feeling about that. That's probably a text field where you put in the annual interest rate. TF, number of years. Well, that sounds to me like it's a text field that tells you the number of years. So if you name your things with clarity, you really reduce your reliance on commenting. And one of the things that I stress throughout this course is a general rule. If you have a lot of comments in your code, that what that means really is you have bad code. Ideally, you want the code to be understandable by a reasonable observer without a whole bunch of comments. In fact, look at this comment. They have this override tag. This is not required, but it's suggested. It tells the Java compiler that you're about to override a method. And then they say, override start in the application class. I kind of knew that already because you just said override and then the next thing that happens is start. So, so that's kind of what I'm telling you, useless comments. All they do is clutter up your code. We knew that, right? Without. As always, the GUI extends application. And then we have the start method in lieu of the main method. I guarantee if we go to the bottom of this file, we will find a main method. And its only job, remember, when you're doing GUI stuff, the only job of the main method is to allow support for systems that don't look for the start method. And so all the main method is going to do is launch args, which launches the start method. And sure enough, at the bottom, there it is. Main method, launch args. It's only there for systems that don't explicitly support the start method. And I recommend that you keep it. I recommend that you do that. It would be, it's about programming defensively, right? Make sure that your program will operate in as many different environments as possible. Creating this setup is not too difficult. Notice, by the way, how pretty it is. If I change the size, oh, it stays attractive. Good. This is telling you something. It's telling you that they probably used a grid pane to lay out these elements in a grid. And sure enough, if we look at the kind of pane that they imported into the code, it's a grid pane. So now what do? Grid pane equals new grid pane. Then they add a label, and then they add the interest rate text field. And remember, in a grid pane, you have to specify, it's a 2D grid, so you specify which column and which row you're going to put things in. So the label is in column 0, row 0. There it is, annual interest rate up in the upper left-hand portion of the grid pane. The text field for interest rate is in the first column, 0th row, and there it is right at the top, first column, 0th row. And again, the only thing that's weird about a grid pane is we're so used to doing horizontal, vertical, row, column. That's the normal way that you refer to matrices. It's how we all grew up dealing with the XY coordinate system, X first, then Y. And here it's reversed. It's column first, then row. And how would you know? If you forgot and you started to build your grid pane, then you would see that everything came out flopped, transposed 90 degrees out from what you thought. And so you would just go back and change it. Small comment, by the way, if I was coding this from scratch, I would have done these 2 lines of code and I would have stopped, compile, run, and make sure they showed up the way I wanted them to. And once I did those, then I would probably do the rest. So they add all these labels and text fields and labels and text fields and labels and text fields, and all they're doing is telling you where they are in terms of column, row in the grid. And then lastly, they add the button in the first column, 5th row. That's the first column, 1, 2, 3, 4, I'm sorry, 0, 1, 2, 3, 4, 5. So there it is on the very bottom. How did they get it to align nicely on the right-hand side? If we look, grid pane, set horizontal alignment, BT calculate, sorry. Grid pane, set horizontal alignment, BT calculate, H position right. Oh my gosh, how would you know how to do that? That's what tutorials are for. That's what code like this is for. And again, you can do all kinds of things. Then they have to get the button to do something. If you press the button, something should happen. And this is the line that makes that happen right here, line 49. BT calculate, set on action. And set on action is the action that you're going to use for the button virtually all the time. Set on action. What's the action for a button? The button gets pressed. Or technically you put your mouse over it and click. So if the button gets pressed, that's the action that occurs. And the format for these, there are different forms of format. The author presents 3 different ways. You're going to learn about a separate way in lab, but this, in my opinion, is by far the easiest. It's just this: E, arrow, and then the name of a method or a code snippet that you want to activate when that button gets pressed. E stands for event. What's the event? The button getting pressed is an event. There are several different classes of events inside or recognized by JavaFX. A mouse click is an event. A key click is an event. A button press is an event. And so you can specify this. E is just general shorthand for event. It is not required, but it is, I don't believe it is required, but it is customary usage. So E, event. It says when this event occurs, and then that arrow sign, you literally make that using the negative sign and the greater than sign. When this event occurs, execute the calculate loan payment method. So that's how you're going to tie your GUI to the model. And this is a very simple example. So the controller is built right into the GUI here. All right, so what does calculate loan payment do? And again, you would need to think through this ahead of time. What the calculate loan payment needs to do, let's not look at the code yet. If we look over here, what does it need to do? Well, let's see, I've filled in my interest rate. I filled in the number of years. Let's say it's a 5-year car loan, and there's the loan amount. So what do we need to do? We need to get those values out of the text fields. We need to get 2.5 and 5 and 22,000 out of the text fields. And then we need to send that over to the loan object so that the loan object can tell us what the monthly payment will be and the total payment will be. And that's what's going to happen. So if you look, the loan, remember, one of the constructors was, hey, tell me those 3 things. Tell me the interest rate, the number of years, and the loan amount. So how does the GUI get those values out of the text fields? It's quite straightforward. Here's the name of that text field, TF annual interest rate, and it has a method called getText. It's that easy. It gets the text out of the text field. Now, unfortunately, it gets the text as a string. Every time you enter something into the computer, it's assumed to be a string, unless, it's always assumed to be a string. But we don't want it to be a string. We want it to be a double. So that's what this up here is about. Double parse double. In other words, take this string and turn it or convert it into a double. The next one, number of years, we're only allowed integer values. So it says take this string and turn it into an integer. And the third one is take this string and turn it into a double. And that's how we get interest, year, and loan amount. Notice these are local variables inside the method. That's fine. Once they have those 3 things, then they create a brand new loan object inside the variable. It's not an attribute. That loan object is a variable inside of the calculate loan payment method, and there's nothing wrong with that because they're basically going to do one-time use. It's not like you need that to be a persistent object because you're going to keep monkeying around with things. If you want to try different combinations of interest rate, years, and amount, then it'll just keep making new objects for each one, and that's fine. Okay, so once we have that, we get the text. How do we put the new text back into these text fields down here, into the monthly payment and total payment? Well, if get text is how you get the text out, set text. So that's what's happening here. The name of the button, TF monthly payment, set text. What are we going to set it to? Well, we're going to ask the loan to tell us what the monthly payment is. So this loan.getMonthlyPayment, remember you set that up in the loan object, or whoever created this set this up in the loan object to be able to get the monthly payment, and it returns the monthly payment. So now we have it and we can put it inside of the text box. The only thing that's a little unusual here now is they don't want it to be, they don't want the monthly payment to be $399.44682593, right? That doesn't make any sense. It has to be dollars and cents. So what do? They format the string. They format the string to be $%2F, meaning $, followed by a double with 2 places past the decimal point. Those of you that took C will be familiar with this. Those of you that took MATLAB, this might be new to you. Same trick for the total payment. You say the name of that text field total payment, set the text. What are you going to set it to? Well, ask the loan object what the total payment is. It will calculate the total payment. And then you do the same trick. You just format it as a $, a double with 2 decimal points. So it's going to be dollars and cents. So I think this is a I like this example because it's fairly straightforward. It's simple enough to get your arms wrapped around. And the thing that's important is we have the GUI. All this grid pane stuff is the view. The loan object itself is the model. And then in order to tie the view to the model, in other words, the controller, you create this method to calculate the loan payment information. And you tie it to the button using that, E @ calculate loan payment. As usual, I recommend that you make methods that do little tiny things. Right? Don't have methods that do a whole bunch of work. How many lines of code is the methods in here that actually do the work? Let's see, there they are, get monthly payment and get total payment. Get monthly payment is 1, 2, 3, 4, what, 5 lines big? Find total payment is 3 lines big. Oh, and by the way, how did they make it so small? They called get monthly payment as part of it. Methods are allowed to call other methods, that's okay. So each method is nice and small and does one small specific thing. That's good design. Inside here, the method of calculate loan payment, that method is all of 58, 68, so it's 16 lines long, of which 1, 2, 3, 4, 5 of those are 5 of those are comments or blanks, and 2 of them are actually wraparound of. So basically, it's 9 lines long. So there's a good first example of how to get user interaction. Now, like I said, today we'll do these where it's static. There's nothing moving on the screen. You just fill in some information and you click some buttons and things happen. And on Wednesday, we're going to talk about timelines. Timelines are a version of animation. And during the animation, you can make things happen also by setting up events to kick off methods. And the events may be key clicks, the events may be mouse clicks, the events may be button presses, but you can use that form right there. Okay, there's our first example. Do we have questions about the first example? Oh, for God's sake, I thought I got rid of you. Okay. Let me run this one more time. What if we put in 2.5 and a 30-year loan for a house? It's a $125,000 house, and then we can calculate a value. What if I put in a comma in here like some people do? Oh, that causes problems because it was expecting, it's trying to read a double, right? And we put a comma in there. That's trouble. Whoops. There we go. Yeah, that's better. What if I put in 30.5? Remember that was supposed to be an integer value? want to see a rapid change. So what do we got, $474? Yeah, see, it didn't, basically it's giving us error messages, but we can't see it there. There, now it's fixed. What if I put in negative for loan value? That's okay, I just get money back. Instead of paying money in, I get money back. So these kinds of perverse values that I was putting in, these are the kinds of things that you want to play around with. Code that I'm giving you, try to break it. And your own code. Try to break it. See what works and what doesn't work. If you were to really spend time on this and fix it, you could see it would get a lot more complicated. For example, the number of years should never be negative, -20. Well, it allows that, doesn't it? Number of years is probably shouldn't be negative. So you would actually have to change your code to protect against that. Like under the set number of years line here, this might get replaced with if number of years is greater than 0, then this is number of years. Otherwise, default to 1 year. Oh, and probably should print out a warning to the user. If you're going to actually code defensively, then you do need to add in more stuff here. When we do exception handling, this would also be an opportunity for exception handling. All right. Let me move on to the second example. Okay, so the idea here is, this actually came from a student project, and I thought it made a nice example. And what the student was saying was, their project is they wanted to have a terrain map, and then they wanted to show if water level rise, if floods came, that they would be able to show on their terrain map what pieces of land went underwater. And so I took that and made a really simple version of that. And the reason it's so simple is actually because my terrain map is not real terrain. I have randomized terrain. So this looks kind of, my flood map here looks kind of insane because it's just random values. Now by a terrain map, you've all seen these maps where they designate the height of the terrain based on color. So maybe when really low values are like a dark green, and then the higher values are more yellowies, and the even higher they might get up into oranges and dark ochres and things like that. So that's the idea. If I wanted to, I could modify this to represent, Daytona Beach area or, San Francisco Bay or whatever. But for now, it's just random, completely random. And so you start to ask yourself when you're designing this thing, no, I don't want that. I want that. What objects do I need? Well, I actually need the map itself. I need the map. And then I need the GUI. And then I need some kind of controller. And as you get more sophisticated, now my map is the model. It only has one class. In your projects, the model will have multiple classes, right? Because you're going to have, remember, you have to have an inheritance requirement. So like in the sheep-dog game, you've seen my model. It's got the generic animal, and then that extends to the sheep, that extends to the dog. It's got terrain. So the model generally have more than one class, or more than one object. So once you identify what your objects are, then you have to ask yourself, what attributes does the map need to have? And then you get into, well, gosh, how am I going to represent the map, right? How am I going to represent terrain elevation in a model, not visually. Visually is how it shows up when you're looking at a map, but a math model. And a standard way to do this in map world and in simulations is called a post map. And so what you can do is create a two-dimensional grid. And if you imagine a two-dimensional grid laid out over your town, and maybe it's every square meter is one grid, you could take each square meter and get an average elevation for that square meter or square kilometer. And then, you go over one and you get another average elevation, and you go over and get another average elevation. And what you're going to end up with is a two-dimensional array that shows the average height or elevation at each grid inside the town. And people call that a post map because they think of it as putting a post in the ground of that particular height at each location. And this is a real way people make terrains and simulations. So we need to have some kind of a post map. I don't know what I'm going to call it yet, but we need it to be a post map, and it needs to be two-dimensional. So that's going to be the attributes. And then what methods do we need? Well, this is a simple example. It doesn't do much, right? I probably need a way to initialize it. And I'm just going to do that randomly because I'm not doing real terrain. I'm doing a random thing. And then I probably need a way to tell people about the post map. Now, what do I think the other objects are interested in? Again, think about what questions are the other objects going to ask of the map? What function does this map serve? What questions might you as a human ask of this map? And one would be to get all the data. But another one might be to get a single element inside. So probably get and it's going to return the value or the post height at a specific row and column. And then what can I do? Well, if inside the GUI I make a bunch of rectangles, and the number of rows in my rectangle grid is equal to the number of rows in my post map grid, and the number of columns in my rectangle grid are the same as the number of columns in the post map grid. And for each rectangle in my two-dimensional rectangle array, I can go and ask the post map, hey, how big is your post, right? What value do you have? And then I can color the map accordingly based on that. So there are two distinct things going on here. One is what you're looking at now on the screen. That's the view, that's the map. It is not the actual terrain. It's a representation of the terrain. The actual terrain, if you will, let me misuse the word actual, the actual terrain is actually the post map that has the height data for each of those rectangles, for each rectangle of land. So now that I know these things, okay, I can create a map, I can create a GUI. What's the GUI going to have? Well, the GUI has to have a stage, and a scene goes in the stage, and then a pane goes in the scene, and then I have a whole bunch of rectangles. A 2D array of rectangles. And since I'm going to start to put some GUI interaction in there, that pane is going to get kind of ugly. Creating all those rectangles, and eventually see the buttons that I have down there, creating the rectangles, creating the buttons, creating the methods that will actually address the model, that's going to get pretty ugly. So I am going to have a separate class just for the pane. And I do recommend that you do this for your project. You keep your top level GUI pretty clean. You do all the dirty work at the pane level. And all you have to do when you're creating the pane class then is at the highest level, you say, build me one of those things. So if we look at the code, let's see what I have here. I want this one. Here's my post map. This is the actual model of the terrain. It's really simple. All it has is a bunch of posts. Right? That's all it has, a 2D array of posts, which represent the average elevation of a hunk of terrain in some imaginary map. And then the methods that we have, well, here's my make random map method. And then I can set an individual element and I can get an individual element. So my class itself is quite small, again, because it's so simple. But that's okay. Your classes, you're allowed to have classes this simple, it's fine. If you have something that does a special purpose job and it doesn't take very many lines of code to describe what that special purpose job is, there's nothing wrong with that. Then we have the GUI, and the GUI is quite simple. Because what did I do? I put all the details down in the map pane itself. That's going to be my thing that eventually coordinates between the view and the model. So that's going to serve as my control. So it's really short. I built my own map pane off to the side in a separate class, so I don't have all those details cluttering up the top end GUI class, the main GUI class. And so all I have to do is say, build me one of these panes. Oh, and I'll put the pane in the scene, put the scene in the stage and show it. I mean, my top level GUI becomes that simple. The details are here in the pane. So let's see if I run this thing. This is whoops, that's not right. On the top level. There we go. This is my non-interactive version. I did this before I put the buttons in. And I recommend you do that too. Don't build everything at once. You build out your functionality piece by piece. So the first thing I wanted to do is convince myself that I could actually build an array of rectangles, and that I could build out an array of posts and have the posts and the rectangles actually make sense with each other. That the rectangles would be colored properly based on the post. By the way, the fact that I have black in here means technically I didn't do it correctly. Oh well. So how did I build the pane? So what you're seeing, this is the stage. The stage has even the show rectangle still. The stage still has the title and has the widgets. The scene is inside, that's the entire window. And then the pane takes up the whole window also, because I only have one pane in here, but the pane is composed at this point of just a two-dimensional array of rectangles, and I give them their colors based on the corresponding height of the hunk of land that they're trying to represent. And so how did I build that? Pretty straightforward. I built my map object inside the pane. That way my controller can talk to it. I built a two-dimensional array of rectangles. I went ahead and set the water level at 3 just to begin with, just so I could practice, convince myself that my color, color everything that's underwater should be blue, right? That I can practice that. And then I set the rectangle size to 12. Why did I need the rectangle size to 12? Well, remember, I'm going to have to add each individual rectangle to the pane, and I'm going to have to position it. And what I want is just what you saw. I want them to lay out in a row, one after the other. Bing, 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 right? Rectangle, 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 rectangle. Well, I need to know how many pixels to move over. So if each rectangle, I've made them 12 pixels big, Then I put the first one here, 12 pixels over, 12 pixels over, 12 pixels over, 12 pixels over. I keep doing that until I have the entire first row done. Then I come down 12 pixels and do it again. Then I come down 12 pixels and I do it again. So this is my constructor for the map pane. Map pane extends pane. I recommend that you do this kind of thing. Use a pane, then you can extend it. Then when you extend it, you can put in all kinds of the special purpose things that you need. So map pane extends pane. The first thing I do, remember, I've already got my post map made. It exists. It doesn't have any good data in it yet. So the first thing I do is say, okay, give me good data. Give me a random terrain. And then I say, now that I've got my model, now I'm going to start making my view. Create the rectangles in pane. Oh, okay. So what did I do? All of this is just a bunch of method calls. Again, each method should do a fairly straightforward, simple job. And that way you can read through it and see what's happening. Oh, the first thing we do is we make a map. Then we make rectangles. Then we color the rectangles. Then we color the water level. So I make the random map. I make the rectangles. They don't have the right color yet. I color them. Now they're going to, hopefully their color will match their height in the random map. And then I'm going to color the water level. So everybody who's underwater will be blue. And in this case, my water level was initially set at 3. So everybody who's less than 3 will be blue. By the way, I just artificially had my map create values between 0 and 10. So that's why 3 is underwater. So you look at all these different methods to see the details of what's going on, but notice each method does a fairly small discrete task, right? A fairly small contained task. Okay. So what does create rectangles in pane look like? See, it's a small number of lines of code. I create the rectangles in the pane, and how do I do that? I create a new 2D array of rectangles. N and M are clearly the rows and columns that I want. I create a new array of rectangles, and then I have to go through a nested loop because it's a 2D array, right? So I have to go for every row, every column. Right? So it's a nested loop. And I create an individual rectangle at that location. And when you create an individual rectangle, remember it's X location, Y location, horizontal size, vertical size, and my X location. Cute trick. All I did is I offset it 50 pixels from the left-hand side, and then it's R size times I. In other words, that's what's going to lay out rectangle after rectangle after rectangle in every row. And then for the Y direction, I just offset it 30 pixels from the top, and then it's R size times J. So that's what's going to give me rectangle, 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 rectangle to make the rows. Once I've created it, I set its outline to black. I set its insides to white because I haven't colored it yet based on the flood map. And then I added it to the pane. So remember the thing about, I said I had an array of rectangles, a 2D array of rectangles. Really what I have is a 2D array of places to put rectangles. So I have to go through and literally create every rectangle in there. Now I've got a rectangle in every slot in that 2D array. Once I create the rectangles, I'm going to color the rectangles. So here we go, color the rectangles. And that's fairly straightforward. It's just a switch statement. I know my rectangles are going to be integer values between 0 and 10. When I was designing this, I didn't think about 10, so I actually stopped at case 9. But you'll see I have those black rectangles in there. That means some of them were actually at 10. So, oh well, I can fix that. And again, I have to go through for every rectangle. I have to find out the value or the height of that specific element. And I do that using map get element, and then I can color the rectangle. I still don't have interaction yet, really. All I've got is the ability to color the rectangles. And then for coloring water, all I do is, again, I have to go through my nested loop and check every single rectangle. And if the height of the rectangle is less than or equal to the height of the water, I'm going to paint it green. By the way, the thing that took me longest for this code was deciding on these RGB values for the color. I spent, I don't know, 4 hours on that. It was, you can get overly obsessed. That was being overly obsessed. You can get overly obsessed with good color values. Now again, look at this code. Try to write your own code to do something. That's how you're going to learn. These are fair enough examples, but that's how you're going to learn. Okay, the next version of that, we actually added the interaction. So here we have some simple interaction. And now it's the same thing, but I've added the buttons, and I have 0 meters, no water, 3 meters. Oh, some of them are at 0 height. That's why there's still some blue. 3 meters, 5 meters, 8 meters. So now I have interaction. Simple interaction, no animations yet, just simple interaction. How did I do that? Well, think about what I've already built. All I have to do now is add the buttons and position them. And then for each button, I do a set on action, do something. That's all I have to do. So if we look in the interactive version, everything looks the same, except I added this new method, make buttons for water level. First, I put a label above the top, select the water level, to give the user some instruction. And then I added that label to the pane. And then I did buttons. Now again, preface your button names with BT. BT are a mnemonic that it's a button. BT0, that's going to be the button for the 0 water level. BT3, BT5, right, for the 3 and 5 meter water levels. And all I do for each button, once you do one of them, again, build one of them and see if it works. Once you build one and you see how it works, then you can cut and paste to your heart's content. So BT0, 0 button, 0 meters. I have to set it in the X location. I have to set it in the Y location. Now, the reason I did it this way is because if I ever change the number of rows that I had, then it would automatically push down or rise up to match the number of rows in the map itself. And then here's my set on action. For this event, arrow sign, again, that's the minus sign greater than sign. For this event, do this snippet of code. And you'll notice this snippet of code is inside of the curly brackets. Remember, one of the wonderful things about Java, curly brackets always mean sections of code. So what is the sections of code? I need you to do two things. I need you to color the rectangles and then color the water level. When I first created this, I only had color the water level in there. And then it turned out, well, that didn't work because once I went up to 8 meters, it would never go back down to 3 meters. So I had to go say, okay, color it as if there was no water and then color the water. So I'm executing those two methods inside the code. And I do that for every one. All I do is I change the height. Now, I did have to modify my color water level because before it was 3, right? I just fixed it at 3 meters. So I did have to modify where'd it go. Color water level to take in water level as a new input attribute. But other than that, I just added that method, and color water level for the 3 button is going to do 3. Color water for the 0, it's going to do 0. If I look at my top level constructor, still nice and clean. You should be able to read that. Again, if I did it right, then you can read that and have a really good guess as to what's going on. Oh, first we make a random map, then we create the rectangles, then we color the rectangles, then we make the buttons, and then we color the water level. Thinking at this top level is helpful because you don't have to solve all your problems all at once. You just know you have to do something, right? So make random map. Okay, I'm going to make them all with the same height. They all have a height of 0. Right? Then you make a better version where it's randomized. If I were to keep going with this, I'd make an even better version where I could pull in files, and then I would make files that represented actual terrain in the real world. Create rectangles in the pane. Yeah, create them. They're all white and they show up. That's all you need to do. Color the rectangles. Yeah, color them all green first to convince yourself you can do it. Then add to that method where you say, okay, I'm actually going to check the color against the post note. Make the buttons for water level. Make one, see if it works. If it works, you can make the other 3 really easily. Color the water level, same trick. The first time you make it, maybe nobody's blue, or maybe everybody's blue. And then after that, you actually check against the height. But if you think at these top levels, I'm going to let you go. If you think at these top levels, what you're going to get is a high level idea of what you need to do. And then on any individual day when you're programming, you can say, I'm going to attack this method, right? That's what your user stories are all about. Chunking out the functionality and then saying, okay, I'm going to attack just this, just this, just this. Okay. I cannot recommend enough that this code is available to you on Canvas, and by all means, take it, play with it, break it, try to write your own code that does something really simple. And I will see you guys on Wednesday. We're going to talk about the timelines on Wednesday, and I'll show you a couple